Okay, so this is the second method that we can use to solve linear quadratic systems of equations. And we did this when we solved linear to linear, so it's the same idea that we want to be able to add the equations together and eliminate a variable. But in this case, we only want to try to eliminate y. You can see that if we try to manipulate these equations to eliminate x, what would happen is we'd still be left with x squared and y, which would be a problem. So we're only going to work to eliminate y. So these two equations are already set up nice and neatly so that we can easily do that. So I'm going to multiply this second equation here. My pen's not working. Okay, here we go. By -1. So my first equation I'm going to leave alone and have y equals x squared plus 4x minus 1. And my second equation, when I multiply through by -1, I'll have negative y. And over here I'm going to align my x's and my constants. So -1 times 3x is -3x, and -1 times 1 is -1. So now when I add the two equations together, I have 0 equals x squared plus x minus 2. So remember, you're adding the equations together. Alright, so now I have this little quadratic to solve. It's already set equal to 0. So I'm going to factor x squared plus x minus 2. X squared is x times x, and factors of -2 that add up to +1, which is my b value, would be +2 and -1. So then x plus 2 equals 0, x minus 1 equals 0, x equals -2, and x equals 1. So there are my x values. And now, just like we did in the substitution method, we're going to substitute those values into either one of the two equations. We've already used both equations, so we're good, and get our y values. So I'm going to use the linear equation. Y equals 3 times -2 plus 1. And so y equals -6 plus 1, which is -5. So I've got this one solution of when x is 2, y is -5. And then I'll substitute in my other x value. Y equals 3 times 1 plus 1, which is 3 plus 1, which is 4. So when x is 1, y is 4. And then, of course, we should check that in the other equation. So 4 minus 1 equals, let's see, let me make that x squared, which would be 4, plus 4 times -2 minus 8, I'm sorry, 4 minus 8 is -4, minus 1 is -5, so that one checks. And then substituting in 1 in the quadratic, I get 1 plus 4, which is 5, minus 1 is 4, so that one also checks. So here's an example of an equation that we could solve by either method. You can see that already the first equation is solved for x. So we could substitute this expression in for x in the second equation. But notice we'd have to square it. And I'm not sure that squaring -1/2 y minus 10 would be so much fun. You can, and it would work as long as you're really careful. But it would be so much easier to take this first equation and multiply it through by 2. Because that's the reciprocal, but it would still leave the y being negative. So 2 times -1/2 is -1y, and then 2 times -10 is -20, and 2 times x is 2x. And now the second equation is not in the same order, so I need to take care of that. I'm going to subtract 4 from both sides. And then I'm going to subtract x squared from both sides too. And so I'll get -x squared. And I did that so it would align with my top equation. So then I get y minus 4 equals -x squared. Notice these are not like terms, 2x and -x squared. So when I add these together, the y's cancel, and I get negative 24 equals negative x squared plus 2x. And I think I'll add x squared to both sides and subtract 2x from both sides, because that way I'm going to get a positive leading term for factoring. So I get x squared minus 2x minus 24 equals 0. And factors of negative 24 that add up to negative 2. Let's see. Negative 24, we've got 2 and 12. The difference isn't 2. We've got 3 and 8. The difference isn't 2. We've got 4 and 6. And so negative 6 and positive 4 will add up to negative 2 and multiply to be negative 24. So my factors are x plus 4 and x minus 6. So x equals negative 4 and x equals positive 6. And as before, I need to substitute those in. So actually, either equation, of course, will work. I think I'll use the first one. So negative 1/2 y minus 10 equals negative 4. So I add 10 to both sides, and I get negative 1/2 y, equals positive 6. And I'll multiply both sides by negative 2 to give me positive 1y equals negative 12. So one solution is negative 4, negative 12. And then I think I'll do the other one over here on the right. So y equals, not y equals, y, I think I'll use the second equation this time. Y plus 6 squared equals 4. So y plus 36 equals 4. And y equals negative 32. So my other solution is 6, negative 32. I will admit I'm making this video kind of quick. I hope that that's correct. But those are our two methods for solving quadratics with a system with a linear and a quadratic. Make sure you do write your solutions as ordered pairs, and you should have 2 most of the time.